Welcome to this session on moment distribution method. In this particular session, we'll be learning how to analyze a continuous beam by moment distribution method. Now, this is a particular problem wherein it is a two-span continuous beam which is being subjected to a concentrated force. One is eccentrically being placed, and other one, 8 kilonewton load, is being placed at the center of the beam, that is at an equidistance from the either of the support. To the statement of the problem, this is the statement of the problem. It is analyze the continuous beam shown in figure by moment distribution method. So it is a two-span continuous beam AB and BC, and span of AB is 5 meter. Likewise, BC is also 5 meter. Only difference is 5 kilonewton load being placed at at an eccentricity, whereas 8 kilonewton load is being placed at the center of the beam. So 5 kilonewton load is being placed at a distance of 3 meters from point A and 2 meters from point B. Whereas 8 kilonewton load is being placed at a distance at the same mid position from the either support. Now if you happen to recall, this is the formula to calculate the fixed end moment for AB and BC will be different because one is eccentrically being placed, that is 5 kilonewton load is being eccentrically being placed, whereas 8 kilonewton load is being placed at the center. Moving ahead, the procedure is quite simple for moment distribution method. Procedure involved here is basically a three-step procedure. So three-step procedure is, first one is to find out the fixed end moment. Next one is distribution factors, and distribution factors, there are hardly two formulas that we need to remember. One is that is 3ei by L, other one is 4ei by L. That is 3ei by L will be used for when the end support is simply supported. There are two formulas. One is 3ei by L and other one is 4ei by L. So 4ei by L is been used when the end supports are fixed. If any other support apart from fixed end supports you have, like simply supported hinge, roller, in that particular situation you are supposed to use the formula as 3i by L. If the end supports are fixed, then it will be 4ei by L. This is nothing but the coefficient that will be required to calculate for distribution factor, and later on is nothing but the distribution table. Fixed end moment, what we have is the common procedure that we are supposed to use for what we had as the fixed sets of formulas, that is for UDL, for simplicity, that is for point load, for uniformly varying load. All those particular formulas that we have learned by slope deflection, the same will be used to calculate the fixed end moments. Now to calculate distribution factor, here this is two-span continuous beam, and two-span continuous beam means here it is support C, support B, and support A. Amongst this particular three-span continuous beam, A is an end support, and C is also an end support. And what if we have support B is an intermediate support, and distribution factor what we have will be calculated for intermediate supports only. Intermediate supports only, the distribution factor will be calculated. Since B is an intermediate support, so B will be considered here, and members connected to B on the left hand side is BA, and on the right hand side will be BC. Once we note down this, we need to look at what type of support A is, and A is just simply supported condition. So formula will be 3i by L. Likewise, once we note down BC, what type of support C is, we need to note down. And C is again a simply supported condition. So formula will be 3i by L. If in case if C had to be fixed, then formula would be here as 4ei by L. But in the statement of the problem, since C is simply supported, formula is 3i by L. In both the cases it is 3 by 5, 3 by 5, and the fraction and the ratio will come out as 0.6. Total stiffness at point B will be 0.6 plus 0.6 because total two members are connected at C. If we had a vertical upward member, vertical downward member, so four members will be connected at point C, at point B. Now since there are two members been connected at point B, You will be noting down how many members been connected at point B. So two members BA and BC. If we add both together, it will come out as 1.2, and total value shall will come out as zero point 0.5 and zero point 0.5 as the distribution factor. So BA will be zero point 0.5 and BC will be 0.5. Then the last is the distribution table. So these are nothing but 6 steps that will be involved. That is, first 3 steps what we have: joint, distribution factor, and fixed end moments. Joints, there are total 3 joints. If I draw the diagram again here, A, B, C, B, and A. There are 3 joints here. A, B, and C. All those particular 3 joints needs to be noted down. 3, C, and A. So fixed end moment at A is minus 2.4, 3.6, minus 5, and plus 5. So these are nothing but the values that we have calculated in the previous few minutes before. Next is releasing the moment. Why we need to release the moment? Because A is simply supported and moment at A has to be 0. Since moment at A has to be 0, and we already have a value of minus 2.4. If I want to make this as 0, I will be adding it as plus 2.4 and ultimately making it as 0. That is what will be noted. Likewise, since C is simply supported, we have the value at C as 5, and we need to make this as 0 by adding minus 5 and make it as 0. So this is the value what we have it as plus 5, minus 5, and 0. Now once since we have added here, this is an external addition of the moment. So this particular value, half of the value will be transferred here. Half of the value means 2.4 divided by 2 will be 1.2 will be transferred here. Similarly, minus 5 divided by 2 will be transferred here. Minus 5 divided by 2 will be minus 2.5. The whole addition will be the modified fixed moment. It is 3.6 plus 1.2 shall be 4.8. Similarly, minus 5 minus 2.5 will be minus 7.5. So this will be termed as modified fixed end moment. So modified fixed end moment is 4.8 and 7.5. So amongst this particular condition, moment at A is 0. So this is satisfied. Moment at C is 0. So that is also satisfied. Now the next job is to ensure that moment at B has to be 0. Now if we happen to observe here, it is 4.8 at one end, minus 7.5 at the other end. So it is not 0 now as of now. So to make it 0, it is 4.8 minus 7.5. Whatever is the value you are going to get, 4.8 minus 7.5, what value will be getting is as 2.7. That is 4.8 minus 7.5. We'll be getting it as minus 2.7. Now once you get this as minus 2.7, the opposite side of minus will be positive. So you are going to give positive for both cases. Whatever the sign you have having here, you are supposed to give the opposite sign for both, that is positive for both. If you happen to get it as positive here, you will be giving the negative sign for both. So 2.7 multiplied by distribution factor. So this value will be 2.7 multiplied by 0.5, that is distribution factor. Similarly, 2.7 multiplied by 0.5, again it will be 1.35. 2.7 multiplied by 0.5, which will be 1.35. So this addition, what we have, 4.8 and 1.35 will come as 6.5 positive. Positive means direction of rotation will be clockwise. Minus 7.5 plus 1.35 will be getting it as negative. Negative means anti-clockwise. So if we add both plus 6.5 and minus 6.5, if we add both, we will be getting it as 0. So this is what is the computation of the final moment by moment distribution method. That is intermediate support, even though it is simply supported, it is equated to 0. Now how it is equated to 0? 6 plus 6.15 minus 6.15 will be 0. So this is how the distribution table needs to be calculated. With the help of these particular values, we are supposed to draw the moment diagram. So moment at A is 0, moment at C is 0, and moment at this particular position it is 6.15. If you happen to observe it is minus means it is anti-clockwise, and this is 6.15. Positive means it is clockwise direction. So this is these two moments put together will try to push the beam upward. Upward push is nothing but a hogging moment. In addition to that, you also have a concentrated force oriented in the downward direction. So this concentrated force that has been placed on AB will create sagging, so it is positive. Likewise, BC it will create sagging, so it should be positive. So these are nothing but a moment that has been caused due to the concentrated load. So this is concentrated load. And moment this has been caused due to the concentrated load. Whereas these two moments, what you have will be created here, which is nothing but the negative moment. Next, moving ahead to this shear, that is shear force diagram. Now, shear force diagram, this will be W B divided by L, and this will be W A divided by L. So this will be W A divided by L. Whereas here it is placed at the center, so it will be W by 2 and W by 2. These are nothing but the shear force due to load. These are shear force due to load. And these are nothing but the values of the shear force due to moment. Now how it is calculated here? 6.15, we have it in the anti-clockwise direction. Resistance force will be in the anti-clockwise direction. Likewise, 6.15 will be in the anti-clockwise, resistance force will be in the clockwise direction. This 5 is nothing but the span of the beam. So span of the beam 3 plus 2 will be 5. And here it will be 2.5 plus 2.5 will come as 5. So 6.15 divided by 5 will come as 1.23, 1.23. Similarly, it will be 1.23 and 1.23. The convention for the forces will be all upward force positive, all downward force negative. So here, since it is downward, so 2 minus 1.23, whereas this is upward, so 3 plus 1.23. So both addition will come out as 0.77, 4.23. Likewise, 4 plus 1.23 will come out as 5.23. 4 minus, y minus because this is downward, so negative. As it is upward, so here it will be positive. Then what we have here is left hand side upward force is positive and right hand side upward force is negative. So 4.23 will be marked downward, whereas 0.77 will be marked upward. Here also this 5.23 is on the left hand side, so it is left hand side upward force is positive. Whereas here 2.77 right hand side upward force is negative. So this will be called as the shear force diagram, and this is how we are supposed to solve a continuous beam by moment distribution method. Thank you. Have a nice day.